on to what we covered last week, difference of perfect squares. And the work related to difference of perfect squares and factorising was found in exercise 8D. So if you haven't done those examples, that's where to start today. So looking at how do we know if it's one of these type of questions or not, basically if the expression has two terms in it, both of those terms are perfect squares, and there's a negative or a minus sign in the middle, it's pretty likely it's going to be a DOPS question, a difference of perfect squares question. Okay, so if you can write the expression where both of those terms are perfect squares and there's a minus in the middle, it's going to be one of these sort of questions. So in the first example, you can see you could rewrite that as x squared take away 2 squared. And in that case, I've got two terms. Both of those terms are perfect squares and there's a minus in the middle. So I'm happy that's a DOPS question. And I know from my experience of expanding these type of things that the factorised form of this expression is going to have two brackets. The start of both brackets is going to have an x in it. The end of both brackets is going to have a 2 in it. And then because I know it's a difference of perfect squares and I know with my understanding of expanding, one bracket's going to be plus and one bracket's going to be minus. And if I want to check that by expanding my brackets, I can. So I would end up with x squared minus 2x. And if I keep going, plus 2x minus 4. The plus 2x and the minus 2x there cancel, and I'm left with x squared minus 4, which is what I started with. Okay, so the factorised form, even though it doesn't look any simpler than the original form, the factorised form of x squared minus 4 is in one bracket x plus 2 and one bracket x minus 2. Okay, so this is the answer here that I'm looking for. Something like the next example, 81x squared minus y squared. Straight away when I see there's two terms there, I would be starting to maybe think it's a difference of perfect squares. Doesn't quite look exactly how I want it at this point. I want to have two terms that are both perfect squares. I know 81 is a perfect square, and I know x squared is a perfect square, and I know y squared is a perfect square. So I'm almost there. I would want to rewrite my first term though as 9x all squared minus y squared. So I've rewritten it now so it is in a form where my first term is a perfect square, my second term is a perfect square, and I have a minus in the middle. So basically I know once I've got it in that form, I know my factorised form is going to have 9x in the front of the bracket and y at the end of the bracket, and one bracket's going to be plus and one bracket's going to be minus. So if I can rearrange things to end up with two perfect square terms with a minus in the middle of them, I know straight away I can get that into two brackets in one step, a plus bracket and a minus bracket. And then you can imagine if you expand that out to check your answer, 9x times 9x is 81x squared. 9x times negative y is negative 9xy. Y times 9x is plus 9xy. And then I'm going to have plus y minus y is minus y squared. Cancel, cancel. 81x squared minus y squared. Exactly what I started with. So I know that that is the correct factorised form of that difference of perfect square expression. Okay, so they can look a little more complicated. The basic idea is if there is two terms in this expression and there's a minus in there somewhere, start thinking it's probably going to be a factorising using a difference of perfect squares. Okay, so sometimes it looks a bit like a difference of perfect squares, like this next example, 2b squared minus 32. The b squared part is a perfect square. the 2 is not, and the 32 is not a perfect square. So I'm sort of thinking it looks a bit like a perfect square, but it's sort of not as well. What I could do to make it into a difference of perfect squares is to take out a common factor first. So if I took out a common factor of 2, what happens then is that 2 removed from that expression leaves me with a difference of perfect squares inside that bracket. So you can see I could rewrite that as 2b squared take away 4 squared. So now I have a difference of perfect square inside the bracket with a 2 outside the bracket. So again, I just leave my 2 outside the bracket, and I know then if I muck around with that difference of perfect squares, b squared minus 4 squared, I can go b in front of both brackets, 4 at the end of both brackets, and a plus and a minus in the brackets. And we're done. So by taking out that common factor of 2 first, it leaves me with a difference of perfect squares inside that bracket, and I can easily then factorise that. So even though that looks pretty messy and it's brackets and things outside brackets and all sorts, and it looks bigger than what I started with, this is still the factorised form of that 2b squared minus 32. So for my final difference of perfect squares example, it sort of doesn't look quite like the ones we're normally used to seeing. The x plus 1 all squared is a perfect square, and the 4 I can rewrite as a perfect square, which is 2 squared. So I'm going to rewrite it again like I have been with some of these others. X plus 1 squared, take away 2 squared. So I've got it now, manipulated those numbers a little bit, so that I have ended up with something squared, take away something else squared. So that is now in the form that it is a difference of perfect squares, 2 perfect squares minus in the middle. So basically I know what's going to happen here is I'm going to end up with 2 brackets. In the first bracket, in the start of the first bracket, I'm going to have an x plus 1. In the start of the second bracket, I'm going to have an x plus 1. Then at the end of each bracket, I'm going to have a 2. And in the first bracket, a plus, the second bracket, a minus. So I've basically just used my same pattern that I've been using all along. The square root of the first square term, the square root of the second square term, a plus in one bracket, a minus in the other bracket. So I can simplify a little bit further by just simplifying these little number parts of the brackets. So I've got in the first bracket x plus 1 plus 2. So I've basically got x plus 3. And in the second bracket, I've got x plus 1 minus 2 is minus 1. So I want you to have a practice with those sorts of examples today. And the work that's related to those sorts of examples is in exercise 8D. So at the end of the video, I'll pop up the suggested questions to do from 8D. And then I want to quickly just move on to the next part of the work today. So those examples we've just done all had 2 terms in the expression. So these new ones here, we call these ones factorising by grouping 2 and 2. So these sorts of expressions have got 4 terms in them. So basically what we're going to do first is start by looking at these expressions in terms of groups. Okay, so I'm going to group the first 2 expressions, or first 2 terms together and the second 2 terms together. And what I'm going to try and do is factorise by taking out a highest common factor the first 2, and then factorise by taking out a highest common factor the second 2. Okay, and then some nice things happen. Okay, so the first one you can see hopefully if I take out an x from that first set of terms, I can rewrite it like that. And then if I took out a highest common factor of 3 in the second 2 terms, something kind of nice happens. So you'll see there that by doing that and taking out a factor of the first two terms and then taking out a factor of the second two terms, I've ended up getting an x plus 2 in both brackets. So what that means is it's one of those that we've done in the past. We can take out a common factor of x plus 2 in one bracket, and then what I'm left with outside the brackets goes in the second bracket, so x plus 3 in the second bracket. So it's quite a convenient method to use if we've got 4 terms in our expression to start with. All right, I'm going to do another one. So again, if we factorise the first two terms and then we factorise the second two terms by taking out a common factor, we hope to get a bracket the same in both parts of that expression. So if I start by taking out an x in the first two terms, and then I take out -5 in the second two terms, I can take out -5 and I'm left with an x, -5 times something to give me -15, and again something nice has happened. So I'm left now with a common factor of both of those two parts of the expression there of x plus 3. And then what's left over can go in my second bracket, x minus 5. What's remaining there goes in the second bracket. So sometimes it's not quite as straightforward as that. Sometimes we do need to rearrange the terms. So there's nothing, you can see I can't take out, there's 4 terms I guess in that expression, and there's nothing I could factorise there with 2x squared and -9. So it doesn't work so nicely. So it's not quite as straightforward as some of the other expressions. But what we can do is actually rearrange this. So if I wrote it 2x squared minus 18x plus x minus 9, all I've done is rearrange the term, so I haven't done anything really to it just yet. Now it seems that there might be factors here that I could do something with. Okay, so if I tried to then factorise the first two terms and the second two terms, now something nice might happen. I'm already starting to see things with 9s and stuff in it, so I'm starting to think this might be a better way to rearrange our 4 terms. If I factorise the first two, and I take out a 2x actually, I'll be left with x minus 9 in that bracket. And this is basically like having 1 times x minus 9. Okay, so if I did that now, you can see I've got an x minus 9 in both parts of that expression, so I could take out the x minus 9, and the leftover parts are going to be a 2x plus 1 to go in the other bracket. So this sort of method, I guess, only works if there's 4 expressions in four terms in the expression. So your challenge today is to work through some examples from exercise 8D and some examples from exercise 8E in terms of difference of perfect squares and factorising by grouping.